Did I ever get to? Nope. Hey guys,
Hey,
how you doing? We doing okay?
I've been better.
Yeah. Trying to find, oh, there it is. This is the last class I have to enter into my grade book. All right, 115. Let's see who's here. Lewis, you here? Lewis? Christina?
I'm here.
Thank you. Nathaniel? Nathaniel? Kelsey? Kelsey? Marie? Marie? Donovan? Okay. Maxwell? This is Thursday's class, right?
Oh, hey, I was actually on mute. I'm here. I'm Donovan.
Thank you, Donovan.
Mhm.
Okay. Armethea, I think I saw you in. Armethea? Nyla? Kaylin, I think I saw you in. Elizabeth? Malin?
Here.
Thank you. Jordan?
Here.
Oh, I'm on a roll here. Mariah?
Here.
Aaron?
I'm here.
Michael?
Here.
I am on a roll. Sheridan? Sheridan? Mila?
I'm here.
Alec? Think I saw you, Alec.
Sorry, my mic was not working.
No problem. Brian, I think I saw you. Brian?
Here.
Sarah?
I'm here.
Alexis, I think I saw you here.
Here.
You like to be called Allie?
I do.
All right, thank you. And I saw Andrew here. Let's go through this one more time, guys. Lewis?
Here.
Nathaniel?
Here.
Kelsey? Kelsey Benini? Marie? Marie Giordani? Armethea, I think I saw you pop in here.
Yeah. Yes, I'm here.
Who is I'm here? Marie?
Yes.
Nyla? Nyla?
Amethia's here too.
Yeah, Armethea, I got you. Nyla? Okay, Elizabeth? Malin?
Here.
All right. So I got missing Elizabeth, Nyla, and Kelsey. Is that true in effect?
Yeah.
All right. So guys, really and truly, I don't care if you can add. I don't care if you can add. The title is not adding in sig figs. The title is measurements in sig figs. I care about your being able to put significant figures together correctly. So I'm more concerned about your being able to give me the right number of sig figs rather than the correct answer. I know that sounds absurd, but I'm teaching you sig figs. I'm not teaching you to add and subtract. All right? All right? Come on, guys. I know
All
it's
right.
7:30.
Yes.
All right.
Thank you.
Yes.
All right, so we're going to go through a little bit of review, hopefully. I know my guys have had it. Have you all had sig figs?
Yes.
Okay, the rules, very simple. 5 rules. All digits are significant. 1, 2, 3, 4, 5, 6, 7, 8, 9. All of those numbers are significant. It's only the zeros we need to worry about. If you got zeros between digits, those are significant. So if I have 5,004, the 2 zeros in between the 5 and the 4 are significant. That number has 4 significant figures. Now, leading zero. A leading zero is a zero that appears before the first digit, to the left of the first digit. It doesn't matter whether there is a period, a decimal point or not. Zeros to the left of the first digit are not significant. So the number 0.00364 has only 3 significant figures. All these three rules are cut and dry. It's only trailing zeros that we have to worry about. A trailing zero is a zero to the right of the last number. If there's a decimal in the number, they are significant. So if I have 3,000.0, because that has the point in there, that has 5 significant figures. If there's no decimal point, they're not significant. So in the number 1 million, there is 1 significant figure. Okay? Now, the rules on operations. Multiplying and dividing. You count the number of sig figs in each number. Your answer has the same number of sig figs as the number you're multiplying or dividing that has the least. So if I'm taking 14,987, that's got 5 significant figures. If I multiply that by 0.54, that has 2 sig figs. So my answer is gonna have 2. Guys, you gotta do the rough math. You gotta do the math where you don't round it before you multiply it. You multiply it and then you do the rounding. In this case, my answer turns out to be 8,092.98. I can only use 2 sig figs. So I'm going to start from the left. The 8 is the first one. The 0 is the second one. That's the last significant figure I can report out. So I look just to the right of that place. I see that that number is greater than 5, so I'm going to round it up. So that the answer is going to be 8.1 times 10 to the third. I use scientific notation to make it easier to designate where my significant figures end. Now, if I take 0.7433 and divide it by 2.74, the first number has 4 sig figs, second number has 3. Sarah, how many sig figs is my answer going to have?
For the
Bottom one.
8,001 for the 8.
No, 0.7433 divided by 2.74.
I apologize. Hold on 1 second.
I'm sorry, I know yawns are contagious. Sarah, how many sig figs? You have a number with 4 significant figures divided by a number with 3. I don't know. It's a perfectly good answer, Sarah.
I don't know. I was
That's-
trying to work it out on the calculator real quick. I'm
can't-
sorry.
You can't work it out on the calculator, Sarah. Now, when you're multiplying or dividing, what you do is you look at the numbers you're multiplying or dividing. In this case,
Oh,
I got
okay.
one with 4 significant figures. I'm dividing it by something with 3 significant figures. My rule says that my answer can only have the same number of sig figs as the number that I'm multiplying or dividing that has the least.
So it
In
would
this
only be 3
case-
significant figures.
Exactly. I divide those two numbers. My answer is going to have 3 sig figs. So my answer is going to be 0.271. We good now?
Yes.
Absolutely, finest kind. Now, there are some anomalies. Sometimes you can multiply a number by another number and come up with the same number. If I multiply 15,000 by 0.99, I've got 2 sig figs in the first factor, I've got 2 in the second. So my answer is going to have 2 in it. I do that math out. The rough number is 14,800. But I can only report out 2 significant figures. So I go from the left, the one is I'm reporting out the place at the 4. I look to the right, that means I'm going to round up. When I round up the 4 to 15, that makes 15,000. Yes, it is possible to multiply something by another thing and come up with the same answer. I can also divide. If I divide 2,000 by 1.0000001, the answer I get is 1,999.9998. But my first factor only have 1 sig fig. So my answer can only have 1 sig fig. That whole thing rounds up to 2,000. Now, the second operation, addition and subtraction. Your answer can only have the same precision. By precision, I'm saying how far the number goes to the right. Your answer can have only the same precision as the least precise number you're adding or subtracting. Guys, the best way to do addition and subtraction, make sure that when you are putting your numbers down, you are lining them up really, really neatly. If I'm looking at the 6,600, the last significant figure is the 6 that is in the hundreds column. I look at the number below that, 83. That is significant out to the units. Now, units are much more precise than hundreds are. So when I report my answer, I have to report it out to the hundreds. In other words, this is the last digit that I can report out. So all I have to do is draw a straight line down from the hundreds place. So I know that that 6 is the last one that I can report out. I look just to the right, I'm going to round up. Therefore, my answer is 6,700 or 6.7 e to the third.
I have a question.
I'm here, Jordania.
From the previous slide, slide 4, I guess, yes, that's slide 4.
Slide 4.
Yes. Yeah, the answer 2,000, since the significant number should be 1, should we just put 2? Is it gonna be incorrect?
Yes.
Or do we have to put, oh,
Yes, because you need the zeros as placeholders. 2 is not the same as 2000. You're not magically turning 2000 into 2. Okay, Marie? So you have to have the zeros there.
Okay.
2000 divided by 1.00000001 is not equal to 2, Marie. It's equal to 2000.
Okay, I get it.
All right?
Thank you.
Would 2.0 E3 be acceptable?
No.
Okay.
The reason, Alec,
I can't-
because 2000 has 1 sig fig. If you said 2 times e to the third, that would be a correct answer.
Or yeah, that's what I meant. E to the third. Sorry.
You said, I'm sorry, but I have to be
Yeah,
very
I said
specific.
E. I did say E3. Yep.
No,
My
no, it's
apologies.
not. The E3 wasn't the problem, Alec. The
Oh.
problem was you said 2.0.
Oh, okay. Got you.
All right.
Oh,
By
yeah,
saying-
and that would be 2, and that would be 2 sig figs. All right, my
Correct.
mistake.
Okay.
Thank you.
All right. I'm going to do a subtraction. Thank you, Michael, for popping up. Michael.
Yeah.
Okay. Let's look at the first answer. I got 45.987. How many places past the decimal does that number go?
Infinite.
I didn't hear you. How many?
Would it be infinite?
No.
Past the decimal? 3.
3. I've got a significant figure to the third place past the decimal. What about the 0.65?
That would just be 3. That would be 3 as well, would it not be?
No.
Then
Fir-
2.
First of all, the 0 is not significant. It's a leading 0, not significant. Then we have the decimal. This goes out 2 places past the decimal. Is that correct, Michael?
Yep.
So we got the bottom number that goes out 2 places past the decimal. Top number goes 3 places past the decimal.
Yep.
How many places past the decimal can I report out a digit?
2.
2 places. So I do the subtraction. The subtraction I get is 45.337. Since I can only go 2 places past the decimal, I can report out to the hundredths place. I then look to the next place to the right. That number is greater than 5. I round it up. So my true answer is 45.34. We good? Let's go with Marie. Marie, you're out there.
Yes.
All right. I have 45,987. From that, I'm subtracting 650.
Okay.
To what place is the top number precise to?
Mm. 3 significant?
We're not counting the number of significant figures, Judania. I'm counting places. Okay, let's do this. We're going to make a new slide. Okay?
Okay.
Okay. Do you understand this? If I have a number, I need to be able, stop that. I need to be able to determine, in order to do sig figs and adding and subtraction, I need to be able to determine numbers. So if I get 4,503.703, let's put a 2 in there. Okay? Do you see, everybody? Do you see that the 4 is in the thousands place? The 5 is in the hundreds place. The 0 is in the tens place. The 7 is in the
Unit.
tenths
Skip
place.
2.
What?
You
The
skip
2 is
2.
2 is in the units place. 7 is in the tenths place. The 1 is in the hundredths place. The 3 is in the thousands place. Do we all understand this? Are we
Yes.
good with this? We all understand those are the places.
Yes.
Yes.
If I say, how many hundreds do you have? You're going to say that you have 5 because there's a 5 in the hundreds place. If I say, how many tenths do you have? You're going to say 7 because that's the number in the tenths place. Is this making sense to you all?
Yeah.
All right, so we need to be able to determine the most precise place a number is when we are adding and subtracting. So if we have a number, 45,987, what's the furthest number that goes to the right in that number?
9,
Not the 9.
7,
Come on. The 9, there's an 8 and a 7 to the right of the 9. What's the furthest number to the right, Mariah?
7,
The 7. Now, what place is it in, Mariah?
units,
It's in the units. Okay? Now, from that number, I'm subtracting 650, Mariah. What is the last significant figure? What place in the number does the last significant figure? All right, let me back off that. In 650, what is the last significant figure?
the 5,
The 5. What place does it occupy?
the tenths,
Okay,
point
now,
tenths,
what is more precise? The top number that is defined out to the units place, or the bottom number that's only defined out to the tens place?
the top number,
The top number is more precise, so we have to go with the bottom number. The bottom number is only precise to the tens place. So therefore, if I'm looking at this, I have to look there. And the underlying number is the last place that I can report out. I look just to the right of that. It's greater than 5. So the number ends up being 45,340. Questions? I need questions because I know a lot of you are not getting this.
does that always apply to the subtraction?
Always apply to subtraction, always apply to addition.
Thousand, hundred.
Okay. I'm adding these two numbers together. Nathaniel. After I add them together, I get That is the rough. That is the rough number I get.
Okay.
Now, what you have to do is you have to tell me what's the last number that you can report out.
The 10,000th place. So since it's only at since it's 50000 and the top of it, I can only report down to 10,000th place in the bottom, or in the final answer, I guess.
Okay. Basically, you're absolutely right. I really couldn't have said it any better than that. The top number is precise to the 10,000s place. The bottom number is precise to the tens place. Therefore, I can report it out only to the 10,000s place.
So would this one end up then, since it's 5,380 at the ending, we're gonna have to round that up. So this is gonna end up at 1,300,000, I guess. Oh, okay.
All right, if I just write this number, if I just write that number right there,
Hmm.
how do I designate that only the zero directly to the right of the three, that's the only significant zero? How do I do that unless I write that number in scientific notation? There is a way.
There is. Oh.
There's an archaic way. If you put a horizontal line over that zero, that will designate that zero as the last significant figure. It's an archaic way of doing it, but it still does work. Easiest way, guys, don't learn two ways. Just turn it into scientific notation. Now, do I have any questions on this?
Did we only have to convert it to scientific notation just because there's so many zeros at the ending of it that aren't significant?
Yes.
Okay.
Yes. When you have this number, you can't report it out as 1,300,000 because, and you can't, if you put a decimal point, sorry, if you put a decimal point here, what that means is that all the zeros are significant. So what you have to do, you can put the horizontal line over the first zero, or better yet, just write it in scientific notation.
Okay.
On
But
the
if it
test.
was a decimal, we wouldn't have to put it in scientific notation, is what you're saying?
No, what I'm saying is, if this were the answer.
Uh-huh.
right?
Oh, okay. Okay.
On the test, for like our other class, are we gonna have problems where the answer is like this? And then are you want the scientific notation? As opposed to like actually typing it out?
Are you seeing me nod my head? Mila?
Yeah, okay,
Yes, yes. That's
okay,
the only, Mila, that's the only way you can definitively say that there
Right.
are three, that this one is significant and the other three aren't, other four aren't.
okay.
All right. Good. I'm glad I got you there, Mila. I don't know whether, let's do something. No, 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 no. Thank you. No, 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 no. Oh, okay, that'll work. Okay, Mila. You got a number. 0.00654.
Okay,
From this number, you're subtracting 0.0000154.
okay,
All right. The top number, precise to 5 places past the decimal, correct?
yes,
The bottom one goes all the way out to 7.
yes.
So which one is going to limit the significant figures? Top or bottom?
The bottom one.
The
No.
bottom one is more precise.
Oh, yeah. Then the top one.
The top one doesn't go out to the right as far. So
Yeah.
the top one dictates how many sig figs. Guys, draw your columns real neat like this. Then find the number that does not go to the right as far. Draw a vertical line. You would draw a vertical line right there.
Yeah.
Then if you draw that vertical line right there, then you know that the 2 is the last one you can report out. Look directly to the right of that. That number is less than 5,
Yeah. So it
so I
stays.
round down. So the final answer is 0.00652.
Okay.
Questions, ladies and gentlemen? Believe me, you're going to live with this for the next 3 semesters. It's only when you get to organic that you get to alleviate this crap. And believe me, people like me are point thieves. We take points away if you don't give me the right answer. Now, there are also some anomalies. Let me see. Maxwell, you out there? Maxwell? Let's go with Aaron. Thank you, Aaron.
Hello.
Hi. Aaron, would you
Mhm.
agree that the 99.5 goes out to the tenths place?
Yes.
Would you agree that the number below it goes out to the thousandth place?
Yes.
So if the top number goes out to the tenths place and the bottom number goes out to the thousandths place, what's the last number you can report out? What's the last place that you can report out?
The 10th place.
Tenths place. So again, draw your columns real neat. Draw a vertical line. I draw the vertical line, then the 0 is the last one that I can report out. I look just to the right of it, and there's my final number. My final answer is 100.0. But wait, you ended up with 4 significant figures, didn't you, Aaron?
Yeah.
And your 2 answers that you were adding only have 3. Is that right?
No.
Wouldn't it be right though, because you're doing it by the decimal place as
There
opposed
we
to like
go.
actual sig figs?
Absolutely perfect, Mila. Absolutely perfect. Aaron, flip back on here, Aaron.
Yeah.
Good answer, Mila. Aaron, it's an anomaly. If you add numbers, you can gain a significant figure. It's not important when you're adding and subtracting the number of significant figures you have. What's important in adding and subtracting is the place. You can only be as precise as the least precise number. That dictates that when you add these 2 numbers together, it's going to be reported out to the 10th place. Right, Aaron? You were right in the first
Yeah.
place.
Okay.
But that dictates that your final answer, because when you do add these, you add another one to the hundredths column. You add another significant figure to the hundredths column, right?
Yeah.
So yes, it is possible to gain significant figures by adding or lose them by subtracting. Mariah, you there, Mariah?
Yes.
Okay, let's look at the bottom one. All right, Mariah?
All right.
999. What is the last place to the right that's occupied by a number?
The 9, the units,
The units, 9. How about with the 1?
the units,
Okay. So I add 1 to 999, I get 1,000 with a decimal point. How many significant figures does that have, Mariah?
4.
The answer is correct, even though you added something with 3 significant figures and something with 1 significant figure. You ended up with something with 4 significant figures because when you're adding and subtracting, the importance is how far left and right the numbers go. Am I confusing anybody? Is anybody confused here? Talk to me. The only way I know that you're getting this is if you talk to me.
I'm understanding it.
The thousand answer, it's 4 significant figure because of the decimal point, right?
Why is it 4, Jadania?
Because of the decimal point.
Because not, well, oh, why is this? I'm sorry, the 1,000.
Yeah,
Those,
it is.
those 3 zeros in the 1,000
Mhm.
are significant because there is a decimal point. You're right,
Yeah.
okay?
Mhm. Okay.
Are we good with these, guys? Or
Yes.
do you need? Let's do one more. Brian. Have I bothered you yet tonight, Brian?
No.
Okay. I've got 44.5090. This is the bottom equation. Okay. To that, I'm adding 0.67000.
Okay.
How many places past the decimal on the top number? You
Goes to
have
the
a significant
thousands.
number. Which,
Go the thousands.
so you're saying the 9 is the last significant figure,
Would it be 10,000s?
the 10,000s place.
All right.
So the top number is precise, is significant out to the 4 places past the decimal, right?
Yes.
How many places past the decimal is the bottom one?
5.
5 places. So how many places can you report your answer to?
To the
How
what was
many
it,
places past the,
10,000s?
to the 10,000s place? 4 places past the decimal. And guys, you have to, even though these numbers are zeros out here, you have to include them. You have to include them because they are significant. It goes to show how precise your measuring was. Okay, rounding. When you're rounding, you figure out which is the last number that's significant. Look to the next number to the right. If it's 5 or greater, round up. If it's less than 5, round down. All right, questions on significant figures? Guys, this is a workshop. This is meant to be a workshop. This is meant so that you can nail this down. If I'm hearing crickets, I'm going on.
I think I'm gonna need more practice on this.
Armethea, it's amazing. If you look back, you see this thing, Armethea?
Uh-huh.
If you look all the way back, you want practice, I'll give you practice. Module 3. Module 3, where is it at? Amazingly enough, do you see this, Armethea?
Yes, I see
See
it.
that? Is that enough practice for you?
I didn't need practice. That was Jordania.
Oh, Tridania, sorry. Sorry, Tridania, if you need practice. We
Yeah.
have practice for you, okay? Lots and lots of practice. And
Oh,
guys, the correct answers are there. So if you answer a problem and you can't figure out why you got the answer wrong, come and ask me about it, okay?
Okay. Thank you.
You actually just explained it a lot more thoroughly than my chemistry lecture professor did. And now a lot of things I was confused on are actually starting to make sense to me. So thank you for that.
Sarah, this is what I live for. I'm not teaching because of the big money I'm making. Okay? Finest kind. Okay, the second half. First half of this lab is going to test your ability to do sig figs. The other half of the lab is going to test your ability to read measurements. All right. Everything that is measured has an estimated number. When you go to the gas pump and you see the gallons, right now I think some of them go out to 3 digits past the decimal. That third digit out there is an estimated digit. Even though it's in bright lights, even though it seems solid, that third digit is an estimated digit. Whether you're reading it yourself and estimating it, or whether you're getting something to automatically estimate it. Any number, always the number to the far right in any measurement is an estimated number. Okay? So to figure out how to get the estimated, we have to know what part of the number that we know. And we got to figure out what the smallest line is that we absolutely know its value. So anytime you find something that's measuring something else, you are going to find 2 lines that are defined by numbers. 2 lines defined by numbers. Now, what you have to do is you have to realize that that is the range between this line and that line. In this case, the range is 30 minus 20. The range is 10. The next thing I do is once I get the range, I got to count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So what I'm going to do is I'm going to count, make the difference of the 2 lines, the difference of the 2 marked lines, then I'm going to divide that by the number of spaces. So if I do that in this instance, I got 30 minus 20, which is 10, divided by 10. I now know that each small line is worth 1, I'm going to call them milliliters. Okay? If you don't trust yourself, then go back and count them. 21, 22, 23, 24, 25, 26, 27, 28, 29, up to 30. So each line is worth a milliliter. That is the last part of the number that I know. Now I have to estimate 1 more digit to the right. So if I have a meniscus that is right where that arrow is, I know that I have at least 21, 22, 23, 24, 25. I have at least 26, but not 27 milliliters. So my true answer is somewhere between 26 and 27. I'm going to estimate that's looks like about 2/10 of the way up. So if it's 2/10 of the way between 26 and 27, I'm going to estimate that value to be 26.2. Remember, figure out what the smallest line is worth. Then you have to go 1 more decimal place to the right to get your estimated number. And you have to report out an estimated number each and every time. Okay, now I have a burette. Okay, before I was simulating a graduated, before I was simulating a graduated cylinder, you notice how the numbers are going up. If you look at something and the numbers are going up, read them from the bottom up, just like I did. This one, again, the numbers are getting higher as you go up. So that means I'm labeling as 21, 22, 23, 24. I'm reading it going up. On the other hand, if the numbers go down, like in a burette, you have to read them going downwards. So by that, I am not reading this as 23.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. I am not reading this as greater than 23.7. I'm not reading it that way. What I'm reading it as is 22.1, 0.2, somewhere between 22.2 and 22.3. Questions about reading it upwards or downwards? Okay. Jordan, are you out there?
Yeah,
Okay, Jordan. What's the difference between 23 and 22?
ten spaces.
No, not spaces. What's the difference between 22 and 23? How many milliliters is this?
1.
The difference is 1. 10 spaces. How much is each line worth?
0.1 millimeter or
Point-
0.1 milliliter.
0.1 milliliters. So if the lowest line is 0.1, how far are you estimating it, Jordan?
To the hundredth.
To the hundredths. So if I'm reading this, I know that it's at least 22.2, but it's not 22.3. So I'm going to estimate it as 22.7. I'm sorry, 22.27. Questions about that? Sorry, I'm trying to find. Okay. Now you have some funky things. All right. If you do this, the difference between the 25 and the 20 is 5, 10 spaces. Each line is worth a half. That's what the smallest line is. The problem is the half is kind of an estimate to begin with. You can't say it's accurately out to the halfway point. So when you have something that's not a 1, you can't go to the next place to the right. If it's a 1, if the value of the line is a 1, 10, 100, 10th, 100th, thousandth, if it's a 1, you can estimate it one more distance to the right. If it's any number other than 1, you can't. If it's any number other than 1, then that is the estimated digit. Are you with me with that?
Yes.
Yeah.
You just have to accept it. If after you do this math, if the number you get is some factor of 1 or a factor of 10, if it's some factor of 10, then yes, you estimate the next digit to the right. If it's anything other than 10, you don't. In this case, you do the best you can. The 5 is going to be the estimated digit. If it's halfway between the fourth line and the fifth, then 20.5, 21, 21.5, 22. It's halfway between 22 and 22.5. Call it 22.2 or 22.3, whatever you want. That is the estimated digit. Questions on that?
No.
Okay, same thing. Here I have 100 minus 150, 10 spaces. Each one of these lines is worth 5. That means the furthest I can estimate this is to the units place. It's not a 1. If it's not a 1, then whatever the known value is, that also ends up being your estimated value. Whatever your smallest line value is, that will be your estimated value if the number turns out to be not a factor of 10. Questions? Now, this is key. Show your work. Guys, if you just put an answer in the textbook, you get no credit. Even if it's something as simple as doing an average. You have 3 numbers and you want to average them, show it. You need to show all your work. Okay, I'm going to go right now to the, if I can find it. I'm going to go right now to the lesson. And I apologize for taking a little longer than an hour. Okay. The reason I'm doing this is this has some very nice pictures on it. Okay. Triple beam balances. When you are looking at a triple beam balance, the middle bar is how you determine the weight of hundreds. What you do is you slide this over until it fits in one of these little grooves. When it fits in the groove, whatever the arrow is pointed out means that's how much weight is being registered. Tens, same thing. If it's in the groove, it is that number. There's no estimating with the tens bar or the hundreds bar. This just means this is 100. To the 100, I add the 90. This is 190. Now, the front bar. The front bar goes from 0 to 10 divided by individual grams. This does slide. So, reading this, again, I've got my 2 numbers, the 4 and 5, that range is 1. If I would count the spaces, there are 10 spaces. So, the smallest line is 0.1 gram. Factor of 10. Can I estimate this 1 factor over, 1 place over?
Yes, to the hundreds.
So at the line is to the tenths. I can estimate, not only can I must estimate it to the hundreds. So I would read this as 194.51 grams. Anybody not see that? Second example. If I have this one, I'm adding 400 grams to 90, 490, It's past the 1, it's 491, but it's past the 1, but it's not even to the first line. So that is 491.05. Are you conducting something, Mila?
I'm just tired.
I thought you were conducting me there for a second.
I'm just going along with you. I guess 0.02 though instead of 0.05.
Fine. I don't, to be honest with you, I don't care. The only thing I care about is that you know enough to put that second place past the decimal number.
Yeah.
The difference between 0.05 and 0.02 isn't that great. Do I need to do any more of the triple beams, guys? Mila's saying no. Does Mila speak for the whole class?
I think everyone else has their
Yes.
camera off.
Yeah, no.
I'm good.
She speaks for me as well.
Okay, guys, I'm here. Believe me, I'd much rather be eating my pasta fagioli right now rather than doing this talk. I'm here to work with you. Okay. This graduated cylinder, my range between the two numbers is 2. I got 10 spaces. 2 divided by 10, each of my small lines is worth 0.2. Again, not a factor of 10. I can't go beyond. I can't go any more decimals to the right beyond the tenths place. So since these are 0.2, what I'm going to do is if it's on the line, I'm going to call it the even number. If it's between lines, I'm going to call it the odd number. Okay? So I'm looking at this. When you read liquids, you read to the very bottom of the curve of the line. This one looks like it's almost exactly on 3 lines above the 6. 6.2, 6.4, 6.6. Now, let's say it was on this line between the last small line and the 8. If it was halfway between there,
6.9
7.9.
or 7.9. I'm sorry.
It's not this one. This line's 7.8. That line's 8.0. You would read it as Mila said, 7.9. Okay. Are we good, guys?
Yes.
Yes.
Yes, sir.
All right.
Yep.
Yes.
Neela,
Yes.
what is, not Mila, Neela.
Oh, gotcha.
yes.
Gotcha.
Neela,
Yep.
what's the range between the two lines here? How many is it?
10.
10. There are 10 spaces. So what's each small line worth?
0.1.
Not 0.1,
Oh, 1. I'm sorry.
1. So is that a factor of 10?
Yes.
Can you estimate it out one more decimal?
Yes.
So I want you to read this volume.
52.8, maybe 7 or 8.
Perfect. Perfect. Sorry, perfect.
Thank you.
Okay. He doesn't, I don't really like this example, but I have to use it because it's the only thing I have. Let's see. Alec. Alec,
Yes, sir.
what's the difference between these two numbers?
1.
There are 10 spaces between them. So what's each little line worth?
0.1.
So how is that a factor of 10?
Yes.
So do you estimate it out one more digit?
Yeah.
So if you're reading this and you're seeing the meniscus is right exactly on, again, this is a burette, we're reading down. This is 1, 2, almost looks like 3 lines below the 3.
I
But
would
it almost
probably
looks like
say,
Go ahead.
I would probably say 3.29 because it looks close to the 3, but not quite there.
Okay. Perfect answer. Perfect answer. Now the one that is the big problem. I'm trying to figure out. Andrew. Hi, Andrew.
Hello.
Okay, let's look at this. What's the difference between those two numbers?
1 centimeter.
1 centimeter. There are 10 spaces. So what's each little line worth?
0.1 centimeter.
Is that a factor of 10?
Yes.
So can we estimate one more digit? And must we estimate one more digit?
We can and yes.
We can and yes. So the number you have to report is going to be 4 point something something, right, Andrew?
Yep. 4.75 centimeters.
4.75 centimeters. You did a good thing. Generally speaking, this is expanded. If you really look at a ruler, those spaces are really, really tiny. And literally speaking, all you can really tell is if it's halfway between the lines or on one of the lines or the other. But you still have to put that estimated digit. So in that instance, I would say if it's on the line, I would call it 4.70. If it's halfway between the lines, I would call it 4.75. Does that make sense, guys?
Yes.
Yes.
All right. Now, what you're going to do in the experiment. All right. Or what has been given to you. There is a data file. There is a listing of the data in your lab section. First thing you're going to do is you're going to be given 2 weights of 2 different blocks. Okay? Then you are going to have to put both blocks on the scale and weigh them. Then you're going to have to take the first weight and add it to the second weight. Physically, actually numerically with pencil and paper, adding the weight you got the first block at, add that to the weight of the second block, and you're going to compare it to the weight you got of the combined blocks on the scale. Questions about that? Okay. Second part, you're going to calculate the volume of a test tube. What you're going to do is you are going to fill a 100 milliliter graduated cylinder somewhere between 90 and 100. And you're going to write that initial volume. It's already done for you. You're going to write that initial volume down on a piece of paper or in your data table. Then with the water from that graduated cylinder, you're going to transfer it into a test tube. You're going to keep on transferring it, and then you're going to use a pipette to get the last one so you get it at the very brim. Then you're going to record the final volume of the cylinder. Final volume minus initial volume will give you the volume of the liquid, of the test tube itself, since all the water fills all the volume. Questions?
No.
All right.
Are we gonna be looking at the video like the other one?
You can. There is a video. but you are not going to use the video to get your answers, Jadania.
Ah,
I'm sorry.
okay.
I keep on calling you Jadania. Is that what you want me to call you? Or
Excuse me?
would you like me to call you Marie?
Either one is fine.
Okay.
Okay.
All right. Part C. You're going to add between 4 and 5 milliliters of water to a 10 milliliter graduated. Okay. You're going to pour this water into a test tube and you're going to mark it with a grease pencil, Sharpie pen. Okay. Then you're going to dump all the water out. You recorded the volume of the water you put into the test tube. All right. Now you're going to get a beaker and you're going to go out, get a pipette, and you're going to literally put drops in there one by one, and you're going to count all the drops. The last thing you're going to do is you're going to divide the number of drops by the volume of water you transferred. That will give you the number of drops in 1 milliliter. We have any questions there?
Nope.
Part D, they're going to have a block. You're going to have the length, width, and height measurement of that block. You're going to need to calculate the volume by multiplying all three. Part E. Part E, you are going to have a burette with a certain marking on it. And he's going to indicate how much, he's going to indicate what the final volume. Let me describe this better. You have an initial amount in a burette. You drain off an amount of liquid into a flask, and then you stop it. Then you are going to have a final volume of what's left in the burette. Final volume minus initial volume will give you the volume that the burette delivered. Part F, measuring temperature. Basically, they generally have a thermometer in a water bath in the room. Guys, thermometers that measure in tenths of a degree are very, very expensive. What are the chances we're going to give you one that accurate? Most thermometers you deal with are going to be divided into degrees, which means you can estimate to the tenths of a degree. That's the first thing I want to point out here. Second thing I want to point out.
Nail cutters.
I didn't touch them.
Where are they?
Mama, you
What do we
should.
do? Good question.
What?
Donc, dernière fois, tu coupé son mot, tu l'as dit.
Where we somewhere? It's over a month.
Guys,
Au cas où tu t'as dans classe, moi chercher vous, parce que c'est devant là.
sorry, whoever is
Yes.
having a conversation.
Mais viens garder en bas ça.
If you are having a conversation right now, please mute yourself.
It's
Parce qu'il est mal, c'est.
Just make it see what.
Daniel.
Marie?
Oh,
Thank you, Marie. Okay.
I'm sorry.
No, that's fine. All right. This is the formula to change centigrade into Fahrenheit. The thing you need to know about this formula is 1.8 is an exact number, 3.2 is an exact number. So literally speaking, whatever significant figures you read the thermometer at, that's how many significant figures you should end up with in Fahrenheit. Wait, unless of course you get an extra one because it happens to go from like 50 centigrade to 101 Fahrenheit. I'm sorry, I'm trying to make it easy for you and I'm screwing up. Last thing, 3 points, part G, 3 points. if you put something exactly at the, if you have a 10 milliliter cylinder and the last line is the 10 milliliter mark, however precise the entire instrument is, that's how you report the top line. So in the case of the 10 milliliter, it's going to be 10.0. And the 50 milliliter, it's going to be 50.0. Give me points right there. Just write those down. Last thing I want to do, and I promise it's the last thing, because I'm as tired as you are right now, guys. When you go to fill out the results section, I don't want that. By the way, what I just showed you, mass and measurement, lab student results, that's where you're going to go to get your numbers. I think the numbers are all placed here. I'm sorry, I'm looking to see. Yes, that is where you're going to go to get your results. Okay? He's got a sample of a good report. I'm going to show you what I want. As soon as I can find the silly thing. Oh, crap. Damn it. That's what happens when I get tired. I jumped out of the screen. Sorry, I'll be right there, guys. Okay. Are you seeing the picture again? Seeing the screen?
Yeah, we are.
All right. So you go down to mass and measurement volume report, which is where I needed to be. You're going to hit quiz. And you're going to hit start quiz. Okay. Why isn't he in bed, Mila?
He honestly just got out and came. He's yelling, "Mommy, I need you."
Ah,
I had that one.
you have a dinosaur. Okay. All right. Now, he gives you an example. Question 2, calculate the combined mass of both blocks. What I want you to do for this, put the number in there as accurately as you can measure it. Put the label of whether the mass is in grams, pounds, or whatever. Then you need to put a description. It's telling you to add them. Put the description of the second Yeah. I hate that this does this. Equals, I don't know, 70. So you need to have the number, the units, you need to have the operation, the plus sign, and you need to have the descriptions of everything. If you don't have the descriptions, you lose half the points. So if there's no descriptions in this, the most I can give you is 5. The reason it's that harsh is because it's a pain in the ass. I know it's a pain in the ass, but I need to know where those numbers came from in order to help you rehabilitate your report later on when we're trying to figure out what went wrong.
So you want us to like rewrite what you wrote pretty much, is what you're saying?
All you got to do, this is a perfect example.
Yeah.
Whatever he's writing here,
Yeah,
then
like,
write it in the text box.
okay.
Okay. Another thing you can do, I'm going to get out of here. You have post labs in these. If you're worried about what to write in it, go to the post lab. Go to the very end of the experiment. Procedures. You're going to have a little bit of a data table here that's going to help you. Then after the data table, he has a calculations page. This is all you need to put in that text box. Part 1, calculated mass. Mass of block A is this. Mass of block B is this. I have the operation there. Calculated mass of 2 blocks. You have the template right in here if you have nothing else. Guys, I'm about done right now. I really am just about fried. It's getting on 9 o'clock. So I will stay here as long as you have questions, but if you have no questions, and that doesn't mean questions on whether it's a Tyrannosaurus Rex or a raptor.
This page, it's for our personal report, right?
Armethea?
No,
Jordania.
Jordania, I'm sorry, Jordania?
Yes, this page, we have to fill it out for our personal report, right?
I'm never gonna see it, Marie, or I'm not gonna see it.
Yeah, that's why I said for
This is for your
report.
personal, this is for your personal good to know. The only thing that I am gonna see is the report that you write to me.
On that little quiz, that's like our
On that
report.
little quiz, on the little quiz,
Okay.
that's the only thing I ever see. I don't see this, I'm not gonna see your data page.
Okay.
Anything else, ladies and gentlemen?
That's it for me. Have a nice night. Say good night.
Have a nice night.
Good night.
Night.
Don't
Thank
yawn,
you.
Armethea.
I'm
Good
tired.
night.
I
Good
want to
night.
apologize
Good
real
night.
quickly for the weird thing that went into the group or the class chat. This was the culprit. His name is Sander. He's a ball python and he went across my keyboard and decided to
It's
add some, I guess he
cute.
wanted to ask a question.
I thought it was only cats that did that.
No, ball pythons do it too.
The baby.
Oh, he's
Yeah.
cute.
Yeah, he's
So I
cute.
apologize for the weird.
No,
I
show him,
wa-
Sarah, show him to me and the son.
Mommy, their baby name.
David, do you see this? Look at the little baby. Isn't he so cute?
Mommy, I have eyes.
Do you see his eyes?
Yeah. I have working.
Yeah.
Good night.
Good
All right. Say
night.
good night.
Good night.
Good night.
Good
Thank
night.
you.
Night.
Take
Good
care.
night,
guys.
guys. See you Tuesday.
Anybody, if you have any questions, I'm still here. I'm gonna wait till the last person goes away.
I had a question about last night, or not last night, the last lab.
Okay,
Was that last night? Yeah. Well,
That
it was
was
more of
last night.
just, it was more of just a general question. In the lab, I heard like in the videos, I heard the guy talking a lot of, whenever he was measuring something, he referred to mole a lot.
okay.
And I wasn't too sure about what mole is. And I was kind of interested in about when we were going to learn about it.
Okay, I'm sorry, Alec, you are in my class, right? You're
Yeah.
on my lecture?
Yeah, yeah, yeah.
All right, if you look at the schedule, we are gonna learn it right before the next test.
Okay, cool.
Yeah, I'm trying to find, I've got a schedule around here somewhere. I know I do because I had it earlier. Yeah. I don't know the exact date.
I
I
can
don't know
look
the
at it,
exact date.
but now that I know like it's before the next test, I know where to look for it. So I can look and
Okay.
see where it comes from.
Quick answer so that you have an idea about it. A mole is a counting number. Okay?
Yeah, so
Just like,
that's what I figured. Like it's a unit, right? Kind of.
yeah, it's just
Unit
like a
measure.
dozen. Okay,
Yeah.
when you go to a store, you don't buy 12 eggs, you buy a dozen, right?
Yeah.
Okay, if I'm in my chemical storeroom, right? I don't go to get an atom of helium. I go there and get a mole of helium, which is 6.02 times 10 to the 23rd atoms of helium.
Wait, 6.2 times 10 to the 23rd.
Yes.
So wait,
Six-
23 zeros.
Yes.
Okay, that explains a lot.
It's a very,
'Cause-
very, very big number, Alec. And
Yeah.
the reason it's a big number is because atoms are very, very small. So in
Yeah,
order to
see,
get,
I was interested in it because in my high school chemistry class, we didn't really get into moles that much, but my chemistry teacher did just bring it up and he said, to put it into retrospective, if you had a mole of money, you could spend $1 million every day for the rest of your life and never run out.
yeah.
So that's why when I heard him saying it in the lab, I got interested in it and I was assuming, like, oh, well, now I guess I'm going to learn about it now. And
Not quite as much as the last lotto win.
Yeah, right.
But that's all it is. It's a counting number and it enables us to like weigh things out and compare them to one another. Just like
Yeah,
if you
okay.
have a dozen eggs, that's just the same thing.
All right, thank you.
All right, no problem, Alec.
a good
Anybody
night.
else out there?
I think they all left already. I think it's just you and me.
I'm sure. I'm sure they did at this point.
Yeah, all right. You have a good night.
You have a good night too, Alec.